Hello, this is Valentine from Simplistic, and in this problem we have a reaction given to us. A delta H for the reaction is given to us, and the first part is we have to calculate the entropy change in the surroundings associated with this reaction occurring at 25 degrees Celsius. Okay, so the entropy change is given by delta S. So for part A, delta S is always equal to delta H reaction over T. Now what we have to understand is that the question is asking us for the entropy change in the surroundings. So now if the reaction took place, if the reaction gave off, so the reaction took up, not gave off. When you have a positive 163, that means the reaction actually took up 163.2 kilojoules, which means if the reaction is the system, then the surroundings lost that much energy. So therefore delta S surroundings, so I'm just going to move this aside out here and put SURR is equal to minus delta H reaction over T. Why minus? Because we're trying to say that the delta S surroundings actually lost this much heat. Okay, and so now we just have to plug the numbers in to calculate it. So we're going to plug in the 163, so minus 163.2 kilojoules. Now, since delta S is always given calculated in joules per Kelvin, we have to convert this to kilojoules to joules. So multiply by 10 to the power 3, and that'd be joules over kilojoules. And then that whole thing is divided by, if it's 25 degrees Celsius, we want to add 273 to that, so that's 298 Kelvin. And then we simplify that. So we simplify that, we get minus 548 joules per Kelvin. And that's it. That's the delta S for the surroundings. Now the second part of the question asks us to determine the sign of the entropy change for the system. So the system is essentially the reaction out here. So the sign of the entropy change for the system is dictated by, so delta S system is going to be dictated by the change in the number of moles as you go from reactants to products. Okay, so that's going to be, in products we have 2 moles, reactants we have 2 plus 1, so that's 3 moles. So delta S, so the change in the number of moles is going to be 2 minus 3, right? So 2 minus 3, which is negative 1, and since the sign is negative, okay, that means delta S of the system should also be negative. All right, now once we have that, the last part of the question is determine the sign of the entropy change for the universe. So for that, we need to understand that delta S of the universe is equal to delta S of the system plus delta S for the surroundings. So for the sign, since delta S of surroundings is negative and delta S of the system is also negative, therefore if you take 2 negative numbers and you add them together, you get a negative. So I'm just going to write that properly. That's a negative sign. So the delta S of the universe is also negative. The next part of the question is the reaction spontaneous? Well, for a reaction to be spontaneous, the delta S has to be positive. In this case, it's negative, therefore this reaction is non-spontaneous. All right, I hope that made sense. Thank you for watching.